Hello class, this is a continuation on double triangle problems. So in this set of videos, we're working towards calculating a missing angle this time. So let's get to it. So for this, in this first one, starting off rather simple, we're trying to find this angle here. Hope you can see that that angle is found within this triangle. So often it's easier to draw this out. So let's draw that small triangle out. We have W here and 16 here. But notice in this triangle, there's not enough information for us to find the angle. We need at least one more side. But notice that at least this side, which is here, is shared within the larger triangle like so. Let's draw out that larger triangle where this angle is 28 and this side is 18. Not to be confused that 16 is actually going on the inside of this triangle. Notice how if we find this side, it actually gives us this side as well. And once we have this side, we can then find that missing angle. So let's find this side here. Let's label that side A. So A equals, we can see we can utilize A by going with sine in this case. It's opposite and hypotenuse. So sine 28 equals A over 18. Multiplying both sides by 18, we get A equals 18 sine 28. Let's actually type that in for this one because we need that value here. So 18 sine 28, that gives us 8.450488 dot. Now look, we now have this length of A, which is shared here. And now that we have this length, we can actually find W. Because to find W, we can use sine. The opposite, this side here, over the hypotenuse. So let's type this in again. It'll be sine W equals A, which is this length here. So A is 8.4504 over 16. And remember, to find a missing angle, we need to take the inverse trig of this ratio. So W equals sine inverse of 8.4504 all over 16. So that is now what we're going to type in. So W equals, let's take a look at what we get. Equals, so thankfully we can actually do this. We can go the answer, which is the previous one. So shift sine, so inverse sine of our previous answer over 16. And that gives us 31.88 degrees. But converting this into degrees, minutes, and seconds, we get W equals 31 degrees and 53 minutes. All right, rounding to the nearest minute. And that is how we would solve this problem. All right, so let's tackle this next one. You can, of course, pause whenever you'd like to find try and solve the problem yourself. So here we go. For this one, you can see that we have another triangle, well, two triangles. We have one here. And focusing in on this one, again, to find this angle, we need two sides. We have one here, but it's not enough because we need either this one or this one. But I hope you can notice that we can easily find this side because it is shared in this triangle here. So let's label this side here. Let's label that A. And immediately I hope you can see that this is going to be Pythagoras theorem this time. So for this, it's going to be a squared equals 21 squared plus 72 squared. We can type 21 squared and 72 squared. 21 squared plus 72 squared. That gives us 5,625. That is still a squared, but we can find a by taking the square root of that, 5,625. So square root of our previous answer, that becomes 75. But now that we have this side of 75, take a look. Going back to this second triangle, we now have in this second triangle the adjacent and the hypotenuse from x. So adjacent and hypotenuse is cosine. So cos of x is equal to adjacent, which is 45, over the hypotenuse, which is 75. And from here we can see, to find the angle x, we take the inverse cos of 45 over 75. And from here, we solve this problem. So inverse cos of 45 over 75. This gives us 53.13 degrees, but we want this in the nearest minutes. This is going to be 53 degrees and 8 minutes, rounding up to the nearest minutes. All right, so let's box that so we can solve the final problem. And there we have it for this first set of double triangle problems for the missing angle. So I hope to see you in the next set of videos where we tackle these other videos here, or these other examples, sorry. And hope to see you then, and best of luck.